Wednesday. So like if you didn't get all that and you're like, oh my God, this is insane. It's recorded on Wednesday. You can watch that one. I think it's already posted.
There was a few variant in mine, and mine spans like 2 pages, but this is the first ATG right here.
Woohoo!
Yay! But if I were going to the next page, I had to look a little bit, and it's all of this. So I had to find the first ATG.
So you're finding, and for our purposes for this class, we don't really give a crap about the 3' UTR.
The ending
it's just a teaching tool to help you guys understand, how stuff works. But yay, there's the stop codon. Right, and then there's blue or purple or whatever that color is for your 3' UTR. Because we want 5', right? We want that sequence, but just so that you guys understand the whole setup of the gene, and hopefully it'll make sense. And if you're still confused about the setup of gene, just go back and watch that tutorial again, and then you'll be like, oh yeah, right? Because I know it's a lot. All right, good job. Woohoo! All right, is anybody else? Or you can't find it and you need help finding it, we can share your screen and then, we'll work with you to page through.
I think I have it, but I have Intron before it.
Okay.
So I don't know.
Yeah, let's look at it, see if we can find the whole thing. Well, like crunch in between.
So could you see my screen?
Yep. Yeah. Okay.
So I just keep going back until there's white?
Yeah, because you can see your, yeah. So, I'm like, oh wow, what the hell's that?
Yeah, that's,
Okay, hover on the top green and see what it is. See if it still says you're on your gene.
Okay.
Right, I saw that one flash. Is that you?
Gene Loc 107.
That's not you, right?
Let's double check and see.
Yeah, go back to where you were.
USP. Yeah, it's a different gene.
Okay, are we on the right gene now or no?
Yes.
Okay. Okay, so scrolling all the way to, excuse me. Are you all the way to the bottom?
There we go.
Huh.
Our ATG is down here.
Aha. Okay. So we still, which way did you go? Did you go previous page or?
I went backwards and then I was going to go forward, but then I just decided to talk to you.
Okay. Yeah. I don't know what, yeah. Try forward. Let's see what's on the next page. Forward. Because again, sometimes like negative strand, positive strand, I don't know. Do you go backwards? Do you go forwards?
Another ATG here. Oh no, ATA, never mind.
Yeah. Okay, so I think this direction is 3', right?
Right.
Although, I'm confused.
Should I keep going forward?
Yeah. Let's see if we can find the other end. I mean, it's possible that we are on the other strand and it was just randomly, because yeah, this is still your gene, right?
Let's double check again as I go. Yep, this is the gene still.
Yeah, because it's easy when you're flipping pages to just suddenly be on a different gene and be like, crap.
Am I looking for the 3' UTR? Or was that?
We thought you had, yeah, okay. So yeah, so now we're gonna have to go in the other direction and see what's going on, unless nobody's uploaded the, wow. Can you go all the way down to the bottom? Oh shit. Oh, see, now that's somebody else's gene going the other way, right? So hover over that, yeah.
Yep, DKK3. Yeah.
And so you can see it's on the other strand, right? Because that says CTA, right? Is that on the other, or is that the stop codon?
This is CTA.
I think that's yeah, so that's the stop. So this guy's going the opposite direction, right? We're reading right to left for this gene that's not you. And so your 3' UTR ends before that white.
Okay. Oh, I see.
right?
Here.
So if you hover up there, that should be you. Is that you?
Yes. Yes.
Okay, so now we're gonna go whichever way you were clicking, click the opposite way. We'll go back and go back to your methionine and see if we can find that 5' end. Because I felt like it kind of disappeared. Yep, we're still going. Okay.
This is where.
Yeah, and then we have an
Okay.
intron and then more 5' UTR, and then the green. Make sure up there on that green still says it's you.
USP 47, yes.
Okay, so then let's go one more page. And then we should go all the way down. Yeah. See, that's so odd, like how it went, you know, right into the white, like hover on that little piece of green.
H3P.
Okay, so that's not us, right?
Nope.
And that's the very bottom of that page.
This is the bottom of the page.
Okay. See, that's what sucks when like the transition between, like what we got to was intron. We didn't really see another piece of 5' untranslated, right?
Right.
Odd. All right,
So
so
we
go, yeah, go forward again. And then make sure we're all the way
So
down.
we're still here.
Yeah, or all the way up to the very top.
We're still USP 47 at the last C.
Yeah. So let's. Yeah, that's odd. So there's.
I was talking to Leslie, and she said sometimes we splice the intron and then look for the proximal that way.
Yeah, I mean, the only other thing is I'm like, for the actual RNA sequence of your gene, we can blast just the 5' UTR and see what it finds, because this site's saying that whole big green is intron, but then there's no more 5' UTR. So
Right.
how can that be an intron if there isn't exon on the other side? And we just want to make sure if we're PCRing out a promoter, we're not PCRing out in the wrong place.
I'm gonna ask right now. This is Kevin's old gene, just so you know.
Okay.
So I'm gonna see what Leslie comes up with.
Yeah, and see what they
She may have-
PCR'd. Like, I don't even remember, but this is odd. It's not textbook. And you don't want to PCR part of that white if that's really like 10,000 base pairs away from where the promoter should be. Like if your promoter's really part of the green, and for whatever reason it got annotated as that's an intron, but if there's no exon on the other side, or the transition between two pages is missing a line of DNA that is supposed to be purple, like that kind of screws us up.
Yeah. I'm gonna continue to ask, see, because this gene has already been worked on, so
Yeah.
we know something.
And we might need to just click on a different variant too. You know what I mean? To find really where the end is.
I'll do that. I'll do that after the session. I'll look at the different ones.
Okay. All right. Who else needs help?
Need help. I've been scrolling forever and it's just
Kelly's still scrolling. Can you share your? I know, like sometimes, like I said, there can be like 100,000 base pairs in an intron. Which, like, holy shit. But as long as you're hovering and it still says it's your gene, you know. Okay.
Yeah, this is still my gene.
Okay.
There got to a point where it was all ends though.
Oh, okay.
Yeah, that was a while ago too.
You're like, that was a while ago. Because I did look up on Wednesday, I was using some other gene and it had gigantic introns and I was like, all right, I give up, I'm gonna try a different gene. I was trying to teach and I'm like, I can't teach if I can't find a stupid, if I can't find an exon, how am I gonna teach about exons?
Here's white.
Still it, yeah. Okay, so see, without.
I didn't see anything but green in the whole thing.
That's so odd. And the next page is just white. There's nothing at the bottom.
Mhm.
That's so odd.
And I had gone completely in the opposite direction, and I didn't see
And you didn't
anything
see
until I
anything
got to
there?
white again.
I guess we have to pick a new gene. I mean, obviously this is not like if, and I can't believe it, the Kappa locus isn't annotated in here. Like that's just bizarre to me. Unless there was a other variant in, you know, like who just annotates an intron?
This is gonna go on for a while if I keep going.
Yeah. What did your, how many how many of the green lines at the very, before you did sequence view was there? Just out of curiosity. Oh, see, look, it's like a giant, huh, that's weird.
I
Like,
think there's
what?
one variant for the IGK, the variant 4.
Because I'm like, it's either a giant intron or a giant exon, and that's just, you know, not exactly what we're, that's odd.
Should I just choose a different gene?
Yeah, maybe. I'm like, because this one looks like this is exon, you know, here. Oh, you can't see my cursor. Now I'm not sharing. Like the bottom one has dark green and light green, but there's no like, you know, it's like one giant exon and then a whole bunch of,
Yeah.
which that's odd.
All right, I'll just choose something else.
Yeah, I mean, this one seems like it's gonna be hard.
It's all right. Thank you, though.
No, I'm like, right. So sometimes when we're looking for stuff, it's just like, okay, yeah, we could spend weeks trying to figure this one out, or we could just pick something else to make your life a lot easier. Okay. Anybody
Would you
else?
want me to upload the
Yeah,
next one I choose, or I just choose it?
I think I'm gonna add an aisle to our Google sheet because for whatever reason that assignment keeps musically putting other people's uploads into each other's accounts. So we'll just maybe list.
Oh yeah, I forgot to add mine to the Google sheet. I just uploaded the onto the
right, which I
assignment.
didn't ask for originally, but maybe we should just do that and forget the assignment thing because I have no idea why it's letting you upload to other people's. Right, there's like several people's like, wait, somebody else already uploaded under my name, and so we can just put it on that same Google Doc. That'll be easier. And if you're doing the same gene as somebody else, it doesn't really matter, you know, like if you're picking something brand new and you haven't invested any time in it, like, you know, then pick something different, but you know, you can do whatever. So
Thank you.
sure. Sorry that your gene is, that the genomic DNA is not cooperating with us. Kenta, Kevin, Jen, anybody, Nicholas?
I found mine.
Okay. Kitty. Oh, I'm sorry, I'm looking in
the methionine is right
Yay!
here. Yeah, and then this is the upstream, and
Yep.
this is the intron.
Yeah. Okay, good. Perfect. So you're good. So stay right there because we're going to need that, essentially that screen with that farthest 5' sequence in your UTR.
Okay.
And if you want to, you can take a screenshot of the page you're on just so you can always get back to it because there's in the upper right of that page, there's the go to position button. And if you look on the left of the sequences, there's all these crazy numbers. So if you put in one of those numbers into go to position, it'll bring you right back to that spot on this chromosome.
Oh, okay.
So that you don't have to do the scrolling, like you don't have to go back to that original link. And then like some people had to scroll 10 pages to find their, you know, spot.
Okay, do I look for the stop codon?
You can if you want to, just to see what your gene looks like. That yeah, while we're doing somebody else's, you might as well just scroll down or, you know, and just see what's going on the other end.
Okay, sounds good. Thank you.
Okay.
Just give me 1 second.
It's not letting you out. Okay.
I think I found mine.
Okay.
And just Can you see it?
Mm-hmm.
Okay.
Woohoo! Yep. And so it looks like yours runs into another gene. So if you scroll on the green at the top, is that somebody else?
Yeah, that's something else.
Okay. So in this case, right, you can see your, like the AAT in the purple, the 5' end, and then a little bit of white, and then you go into somebody else's intron,
Mm-hmm.
right? Which is fine. We don't care. So yeah, so screenshot this page so that you can always get back to it and then stay on this page because we're going to need to pull sequence from here.
Okay.
All right. Who else? Anybody else need help? Want to find it? Because I just want to show you guys, if you're not there yet, or you need to do it another time and just follow along on the, I posted the slides too, which, you know, walks through what everything means. So the legend and all that, if you can't remember which was green, which was blue, what the hell's going on, that's there. And then the Wednesday recording, because of course I forgot to start this recording at the beginning. But let me go back to mine really fast so that I can show you what we actually need to do. I gotta forget about what we're actually doing. So we want to pull sequence that we think might be our promoter. And as I said at the beginning, our promoter is generally just upstream of our 5' UTR. So we think our promoter is somewhere in here. Most action on promoters is within the first 1,000 base pairs. So for us, we'll want to pull a couple, like, you know, 1,200 base pairs, 1,500 base pairs, just to give us a little breathing room. And you can sort of tell by the numbers here, like the way my screen is pulled open, each row is about 100 base pairs, so 110. So if we counted, you know, this is 100, 200, 3, 4, 5, 6, 7, 8, 9, 10. This is about 1,000, 11, 12, 13. So if I started right here, put my cursor and highlighted, and I want to take all of my 5' UTR, because sometimes there's action that goes on in the 5' UTR for promoters, and it just makes it so that you can always find your promoter sequence by your 5' UTR. And I would take my first, up to my first ATG, and I would just do a copy, and then I might paste it. Word kind of sucks, like, because it doesn't, oh, hello. I'll show you what it looks like. And then Leslie has her little trick for how to make it, or you can just or you can use text only, a text edit file, anything. I mean, for this, we just, right? So it doesn't make each line the same number and it, you know, whatever. But we see, like, because I could pull my ATG, like that will always help me orient where I am. And then I might go back and say, okay, so my 5' UTR is AGTTAC. Right here. So here's where my 5' UTR is, and I'm just going to highlight that, just so I know, you know, where my, so anytime we want to get back to that page also, now we can just take this, any of this sequence, and go back to NCBI and click on BLAST. And so that's just nucleotide, nucleotide find each other. So that's like looking for homologous sequences, right? Complementary sequences. So we can always go back and find this in the database. Even if we forget the name of our gene, we can always just stick in our sequence and it'll find this part in the database. Now, the only problem, or not problem, but except for Tadios, because we don't know exactly where his ends and begins, so we're going to try to figure that out, is remember, like the one in the lecture had an intron in the middle of this 5' UTR. And it was pretty big. It was several thousand base pairs. And if I copy and pasted that whole intron to get to my first ATG, I'd end up having pages and pages of my Word document. So in that case, like, let's pretend that there's an intron here. And I might, just for my own, like I would come up here and I would say, I'm gonna call this, you know, my gene, which is whatever, CD79B, B promoter, which, you know, man, I suck at typing. And my freaking space bar is not working. I wonder if it's because it has granola in it. Okay. Since we don't know it's the promoter, we're gonna put it in quotes, putative. Actually, for this one, we do know because I studied it. Okay, but anyways, so if it was something else, I would write giant intron here. Oh, fuck. See, it's not just my spacebar. I suck. If I could type, I'd be dangerous. Okay, intron here. And then I would then put, you know, my 5' UTR. Or let's say, actually, I should be more. I suck at this game here. Okay, or I lied. We're gonna pretend like it's in the middle of your 5' UTR, right? That was our game. And so I'm gonna write giant intron here, and then find the rest of the purple into that ATG, just so you can orient yourself so later on you don't forget, why don't I have an ATG here? Well, where's the rest of my 5' UTR? Oh yeah, I had that stupid giant intron. So if this is the 5' UTR, right? This is that 5' most A, that means that's where transcription starts, which means this region up here is somewhere where RNA polymerase has to sit and then, right, start doing transcription. So the stuff right upstream should be super important, should be where RNA polymerase sits. And then the other stuff in a eukaryotic promoter is what helps RNA polymerase find that region. So some genes will have from here, if this is your +1 of transcription, some genes will have a TATA box, 27 base pairs upstream. So if we counted 27 base pairs, which this 3, 6, 9, 12, 15, 18, 21, 24, I can't even add 7, it would be right here. Well, there isn't a TATA box here, and guess what? This is not a gene that has a TATA box. So even though you may have been taught that promoters in eukaryotic genes have TATA boxes, only some of them do. But we have to simplify shit for, you know, core classes. So if you do happen to have a TATA box, write 27 to 30 base pairs upstream of your 5' UTR guy right there, then woohoo, then you're pretty sure that's actually a promoter. And so when we PCR it out and test it, we're gonna, you know, we're gonna win. It'll work. When you have a promoter, a TATA-less promoter, then you're just hoping that whoever annotated the 5' UTR is correct, right? Really, is this actually that 5' end, right? This, anything in the database is just what people have uploaded. The Human Genome Project, right, was sequenced in a gazillion different pieces and they put it all together. And then what people upload as their RNAs, they match and annotate onto the genomic DNA. And so if most people that upload an RNA sequence, they're only uploading from mRNA, which is the coding region. And then we're just assuming what's in between the coding regions, those exons, are introns. So if somebody just sucked at sequencing way back when sequencing sucked and we had to do it in the lab and it took 10 hours and it was a freaking nightmare, and you had to walk uphill through the snow, then, right, there can be mistakes. So that's why we want to take a big enough chunk and we want to take the whole 5' UTR just in case it's not exactly the sequences in that RNA. Like what if the 5' UTR really goes to here? So then we're going to look 27 base pairs around for a TATA box. So we want to look for TATA boxes anywhere in this vicinity, and then we'd actually have to experimentally see if it's a real one or not. So everybody wants to pull their sequence, at least 1,000, like I think I pulled 1,300, because our job for next week is to design PCR primers to PCR as closest to the ATG or as close to the end of the 5' UTR before your giant intron, up about 1,000 base pairs. And because this is the sequence we want to take out of the genome, amplify, put it into a plasmid, and test it to see if it drives transcription. So first we have to design primers before we can do PCR. And so we'll design primers. So everybody's going to design their own primers. There's a bunch of rules. There are some programs you can use. And I know a lot of people love their primer programs, but for promoter analysis, we really want to get as close to this ATG as possible, or the end of your 5' UTR, because sometimes there are regulatory sequences in your 5' UTR. So if you just threw this sequence in, let's say we'll pretend like we have a giant intron, and we just put all of this sequence into a primer design program and say, make me PCR primers that are awesome, that program might kick out here, I'm just making this shit up, in here. And that's what you'd PCR. If you did that, you're missing all of this, which is probably the most important part of your promoter. So you're going to actually PCR out something that's totally useless for these studies. Okay, so what we want to do is we want to design a primer as close to this end, or if you don't, like in my case, we don't really have a giant intron. Right, I want my PCR primer to sit right there, god damn it. Not including my ATG, because when we clone it into the vector to do the test, it's a reporter gene that has its own start site. We don't want to start translation and then have a bunch of sequences we use to clone here and then the gene. So we never want to include the ATG, but we'll talk about all that stuff later. So we're going to make our primers out of our brains using what we know, starting with this one down here, because this is the one that's the biggest pain in the ass, because it can't be too GC rich, can't be too AT rich, it has to have all these rules. And then we just want to find one that matches that one somewhere up here, because most of the time the action's actually in about 500 base pairs. We don't really need the 1,000. So we'd rather get all the sequence down here in the super exciting zone and miss out on the BS up here. Okay, and if we can get all of it with a decent set of primers using one that sits right next to the ATG, even better. So that's sort of what we're going to be working on next time. And so again, I'll have a little presentation, I'll post all the rules and stuff, and then you guys will be designing on your own sequence. I'll show you on the generic sequence, and then we'll pretend like we're going to do PCR. And we'll have gels, and we'll show you what actually would happen and all that stuff to do the analysis. So for this week, we just want to make sure you can pull this sequence so that we can start working on it. So if you didn't find it, or you didn't have a gene picked, or your the gene you picked is all green, not helping you, Kelly, then we'll try to get to this point. If you can't get to this point, then just shoot me an email so we can get together before the Friday meeting so that you can be ready, because Fridays, because we only have an hour, it makes it harder to, solve. So we can, work on that just like a one-on-one thing, so that we're all ready to design primers. So, and then just keep this in any document. We'll talk about which documents are better to, number and all that crap next time. But is that okay? Is everybody good? Because now I have to go be on the personnel committee and watch Dr. Van Buskirk's seminar. So I have to, I gotta go. So shoot me email. Let me know if you need me. We'll set up a Zoom time when it's convenient for you, and we'll get you back on track. So Kelly, try to pick one. Try to do it. If you can't, just let me know. We'll get together. Okay. And anybody else that didn't get to, I know, did Kevin show it or Kenta? No, I'm sorry, my K people. Yeah, Sandy too, if she needs help. Anybody who didn't get to go through it. I am here for you. Okay, guys, gotta go. Bye, see ya.
Hi, thank you.
Gotta go, guys, see you later. Thanks.